Welcome to another episode of Code for Thought ByteSized RSE, sponsored by the Universe HPC program. And we continue with our ByteSized RSE mini-series in 2024 with an episode on a tool that is frequently used in high-performance computing called EasyBuild. My guest this time is Jörg Saßmannshausen from Imperial College in London, who incidentally has also run the online ByteSize session a couple of days before this episode is published, and you'll be hearing from Jörg throughout this episode. And since we're still in the new year in January, and it's time to try something new, there will be a quiz on EasyBuild right at the end of this episode, so hang in there. But before Jörg and I go into EasyBuild proper and in more detail, I feel we should talk a little bit about high-performance computing, or HPC for short, in general, to set the scene and help appreciate what EasyBuild does and how it helps. HPCs, or supercomputers, have been around for a long time, and in fact, the Centers for Computing with Powerful Machines is what got the whole computing sector started. Machines like IBM mainframes, or the early supercomputers like the one called Cray, named after the engineer Seymour Cray. Personal computers and laptops, in fact, only became a thing later in the 1980s and 1990s. Nowadays, we associate high-performance computing with the ability to perform complex calculations on large datasets using parallel processing. And there's a pressing need for this, which is why, over the years, the field has grown steadily. The big questions in science today, be that climate change or epidemiology, just think of COVID-19 studies, but also fundamental scientific questions in physics, chemistry, and other areas, require huge computing resources in terms of processing units, memory, and storage. And this is before we start talking about the rise of machine learning, such as large language models like ChatGPT or the open source LLM called Bloom. To run all of that on single computers simply isn't realistic, and sometimes impossible. High-performance computers, on the other hand, make use of clusters of programming units, such as CPUs, central programming units, or GPUs, graphics programming units, by running computational tasks in parallel. This speeds up computation significantly and helps to provide research results in a reasonable amount of time. And so there are supercomputing or HPC centers in many different parts around the globe, like the one at Imperial College, where my guest Jörg Saßmannshausen is based. And in fact, listeners of this program may remember my conversation late 2023 with Nathan Cassereau and Hadim Bourfoun from the Champs-Élysées Supercomputer Center at Paris-Saclay in France. As I said, the demand for HPCs is continuing to grow, and this means we need more engineers to work in this exciting area, perhaps someone like you. There are a number of initiatives that promote HPC services and training, not least this Universe HPC initiative, of which this ByteSized RSE program is part of. It's a great opportunity for research software engineers, but also for researchers in general who find their way into this exciting world, like Jörg, who started his career in chemistry and finally moved into high-performance computing, as you will hear from him in this first part of our conversation.
My name is Jörg Saßmannshausen. I'm working here at Imperial College London at the Information and Communication Department. I'm part of the team which is looking after the high-performance computer cluster of the whole college. So we are a small team, but I'm quite lucky I'm working in a very nice team. So part of my role is to install software. But before I come to that, I think it is worthwhile introducing myself a little bit properly, because most people think, okay, he's one of these IT guys. I'm actually not. I am a fully trained chemist. So I started off working in the lab when I was 15. I've done an apprenticeship as a lab assistant of chemistry. I was working for 2 years in that profession. At the same time, I gained my certificate for university. And also at that time, I actually managed to get my first patent out, something I'm quite proud of. And then, for one reason or another, I decided to go to university, originally from Germany, where I'm from. And then I thought a bit naively, okay, as a student, you need to go abroad. That's the thing to do. So I took up the opportunity of an Erasmus exchange program. So I came over to the UK, to Norwich, and my then supervisor offered me an MSc later on, and consequently a PhD. So I've got my MSc from University of East Anglia in Norwich. But then during my PhD, we moved up to Leeds. So that's the reason I got my PhD from Leeds. Moved down to Oxford once I had my PhD. Done a postdoc there, done a postdoc incidentally here at Imperial. Moved back to Germany, was working at Max Planck Institute for Coal Research. Moved down to Austria to gain my Venia Legendi. That's the license to teach, not to kill. Everybody is safe. Came back to the UK in 2008. We're working for 2 years in Glasgow, still doing chemistry. And back in Austria, I took computational chemistry on site, which meant I had to look into high-performance computing. So in Glasgow, around 2009, I realized, yes, I might have all the qualifications to become a lecturer, but it will be very difficult simply because of my age. I was quite lucky that University College London had a position available in the chemistry department to look after their clusters, plural, more than one. And so they offered me the job, and I took up the offer. So basically, I swapped roles. Instead of doing chemistry as my daytime job and doing IT on the side to support my chemistry, I'm doing IT as my daytime job, still to support my chemistry, because I'm a gentleman scientist these days. So I'm still doing chemistry. I've got an active research portfolio. I've got international collaboration. Currently, I've got one going on with a friend of mine at the University of Leicester. And so I publish about one publication per year, give and take, sometimes two, sometimes nil. It's just things you do on the side.
Okay. And you're at Imperial since when exactly?
I started at Imperial back in March 2022. So it's now...
Right, just after the pandemics.
Just basically when all of that was coming down a little bit.
Well, that's quite an exciting journey. And it took you through all Europe, almost like the Orient Express.
Yes. No murder involved.
No
murder involved. So
not yet, anyway.
I hope it stays like that.
As you heard from Jörg, stepping into a career in HPC through the side door is possible. And in fact, if you think about it, that's how many people end up in roles as research software engineers in general. But let's move on to EasyBuild. HPCs are complex beasts, and that means that things run a bit differently. And I mean not only in the way programs and applications are run, but also how software is built and installed on the system. For one, there are special libraries to do optimized linear algebra computations on large datasets, like for instance the BLAS libraries like OpenBLAS, where BLAS stands for Basic Linear Algebra Subprograms. Then there are the compilers for programming languages like Fortran, which is used in many applications for HPCs, and the type of underlying machines they're compiling the program for, like Intel for instance. Using the right compiler with the right flags makes all the difference when it comes to running your program efficiently and producing meaningful results. In short, putting an application together, say a new simulation to study the progression of an infectious disease, and make it on a parallel computer cluster requires care and work well beyond the coding itself. In some cases, doing all of this manually and putting it together yourself is the best and perhaps even the only option. But often, you can use tools that make building your software easier and faster, particularly if you happen to be a system administrator or a user support engineer on an HPC cluster who has to provide a number of software packages for their users. Which is where EasyBuild comes in. EasyBuild has been created by the high-performance computing team at the University of Ghent in Belgium, and Jörg will tell us a little bit more about the history in a short while. EasyBuild consists of a number of components. Well, first of all, there's the EasyBuild framework itself, which deals with the typical task you do when installing software. Then there is EasyBlocks, which specifies how each installation is carried out specifically, like using make install, or configure. EasyConfigs, where you configure specific information about how to install a given piece of software. And finally, toolchains, which contains a stack of tools to build software, like for instance compilers and numerical packages like OpenBLAS. Well, which is all fair enough. So what is the power of EasyBuild and how does it help you on an HPC cluster? Well, as Jörg will explain in a minute, the task is to build an application that is optimized for use on an HPC cluster, and that means selecting the right version of the modules and libraries you use together with the right compiler and compiler flags. Finding the sweet spot where it not only works but works as efficiently as it can is often a time-consuming task. And this is where EasyBuild comes in. There is a list of configurations for a number of software that you can pick for your purposes. EasyBuild will build, test and install it together with the modules for the respective environment. In my conversation with Jörg, he points out how important it is to have a build process that is reproducible, not only in terms of saving time and effort, but also, and perhaps more importantly, helping to produce robust and reproducible scientific results. So how do you get started with EasyBuild and what you need to do? First, EasyBuild is based on the Python programming language. So what you need is to have Python installed and available on your HPC system. The documentation says that you could still run it with Python 2.7, but it has to be said that the preferred version today would be Python 3. And if you use that, you should have a Python version 3.5 or higher installed with an EasyBuild version of at least 4.0. And as of this recording, EasyBuild is at version 4.9 and I've seen already a version 5.0 being prepared. EasyBuild runs on Linux operating systems, which is what HPCs typically have. There should also be a C and C++ compiler available like GCC or G++, and a modules tool like LMOD. If you tick all those boxes, you can install EasyBuild with a pip install EasyBuild command. The documentation, which by the way is extensive, has a lot of tips how to install EasyBuild and how to check that it runs correctly on your system. You invoke EasyBuild on the command line with the two-letter command EB. The command has a number of different options, and again I encourage you to take a look at the documentation and tutorials, but let me just highlight a couple. The first is the search option, or -S. If you use that, followed by the name of a software you'd like to install, it'll give you a list of existing EasyBuild configs with corresponding compiler toolchains. The command accepts regular expressions as well to do more sophisticated searches. Another useful option is, for instance, the dry run option, which allows you to run an installation process without actually installing the software on your system in case you want to find out what the installation entails and does. There are many other options, of course, and I can't possibly cover them all in this episode. In principle, a workflow with EasyBuild could look like this. Let's say you want to install a package called HDF5. HDF5, which stands for Hierarchical Data Format, and it's often used. Using the search option I just mentioned, you can list existing configurations for HDF5. This may be a long list, depending on how many different versions and compiler toolchains there are. Once you settle on a specific configuration, you can then use it to install it with EB command, followed by the configuration file name. In the simplest case, this should be it. Still, reality is hardly ever that simple, is it? Which finally brings me to my conversation with Jörg, who's been working with EasyBuild at the sharp end. First, I asked him how he got into using EasyBuild and how it helped him in his work in chemistry.
So back in Austria, when I have been asked to do computational chemistry, I was facing a number of challenges. And I think that is actually quite a good starting point because it is explaining my journey and why I think EasyBuild and other programs are actually quite useful here. So one of the challenges is, of course, you have to learn the program. And all of that requires reading quite a lot of manuals and, of course, talking to colleagues. How on earth do I do this? How do I get my input file, which is basically the instruction for the computer how to calculate a molecule? And how do I get the coordinates of the molecule in that input file? So that's one challenge. That's fine. The other one is I said, okay, I want to use the program. And people said, that's fine. That is the code. And I was like, what do you mean by code? All you give me are text files with very funny words in it I don't understand. These funny words, I've been told, is a programming language. It's called Fortran. And you need to compile it. And how do I do that? There are instructions. Now, I was quite lucky that the central IT department noticed he's quite interesting. And so they took me on as a kind of apprentice, but they didn't name it apprentice. So in other words, they took me under their wings and they showed me how to compile a program. Now, compiling is you take these text files, you shove it into a program which is called a compiler, and out comes a binary code which the computer actually understands. And that sounds very trivial, but in that process, you have to bear in mind you are doing number crunching. You want to have that as efficient as possible. You want to do some matrix calculation. Again, that needs to be very efficient, because otherwise you've got basically a Ferrari and you've got me as a driver, which is probably not a good idea. So I've learned all of that the hard way, and I was wondering, is there not a better way of doing it? Now, when I moved down to London back in 2010 and started off working in that IT area in high performance, a bit more intensive, a bit more focused, I thought it might be quite a good idea. Whatever I'm doing, it needs to be reproducible to actually have some nodes. So I started off doing nodes. Probably at the same time, my colleagues in the central IT department did something similar. So they started off saying, okay, whatever we are compiling, we put up the instructions on what is called now GitHub. So there was a need in the community how to compile software in a way that it is reproducible, and also how to compile the software in a way that it is really squeezing out the last drop of the quite expensive hardware you are having. So coming back to EasyBuild, a bit over 10 years ago at the University of Ghent in Belgium, they also had some kind of scripts, and they thought it might be quite a good idea to make that publish on GitHub, for example. So if other people actually are struggling as well, they can use our set of scripts. So there was an initial release 050. So basically they released it to the HPC community first, and the feedback was very positive. In that year, supercomputing in America, they had the official release of EasyBuild 1.
All right, okay, that's the supercomputing, that's the conference, is not it? Or
yes.
The organization that runs the conference?
Yeah, that supercomputing is happening in America. It is one of the large international conferences looking into, well, as the name implies, supercomputing, i.e. HPC. It is not only the computer which is there. In HPC, you need to make sure that these individual compute nodes need to talk to each other in a very fast way. On top of all of that, if you think about it, you've got a hard drive in your computer, or you've got some memory in your mobile phone, and that is limited because you only can store so much data on it, and then your hard drive is full. So we've got the same problem in HPC. Sake of argument, your computer has about 1 terabyte as a hard drive. We've got thousands of users, so we've got quite a lot of data which is produced. So our data storage here is 1,000 times more. In details, we've got 12 petabytes. So that is a really big piece of software. So all of that is in supercomputing.
I think we've got quite a few elements there where EasyBuild can help, because it's not just the translation of a programming language file like Fortran, nowadays probably more like Python or Python-based libraries, into machine code, although Python doesn't need to be compiled for that matter, but it's a bad example, but Fortran. But you also have libraries that you link it to, because a lot of the modules that you build, like the chemistry program, I would imagine that it's building on a number of different programming libraries. They all come in their different versions, and then it's a kind of a combinatory nightmare. Which version works with which version of the other software? And is that what EasyBuild then helps you to minimize the risk of running it?
Yes, that is one of the big advantages of, in general, open source software. Everybody can contribute. So you've got people like me who are chemists who know the chemistry software. You've got people who are bioinformatician, they know the bio software. We've got people who are physicists by training, they know the physicist software. As you already alluded to, at the end of the day, we are doing number crunching. And in order to do that number crunching, there is one library used quite widely, which is called BLAS, Basic Linear Algebra Subroutine. And if you are using the source code as it comes from repository and just compile it, it is very slow. So what people started off doing is we need to optimize it. We need to optimize that BLAS library for the specific CPU microarchitecture we are actually using it for. So CPU microarchitecture, just to explain that a little bit, we all know there is Intel, there is AMD. Meanwhile, ARM, for example, is playing quite a bit of a role in HPC, surprisingly, but interestingly. And all of these different architectures have microarchitectures, which is basically, in a nutshell, the CPU, the core, has some kind of what's called an instruction set. So if you get that problem, they know exactly how to work with it, and they spit out a number in a very efficient way. And these micro instruction sets, AVX, just to put in some numbers, AVX2, AVX512, and whatever it is, all of that is different from different CPUs. That's the microarchitecture. So what some of the programs are doing is basically take the source code, look what kind of hardware I'm having in a general sense, and then compile it. And this is where really the knowledge is. What kind of optimization flags, as it is called, do I need to pass on to the compiler so I get the best high performant, as I call it, software out of it?
And how does EasyBuild do that? Does it do some probing?
It does. I mean, some of the probing is done by the compiler itself. There are compiler flags. There is one if you say the architecture equals native. So the compiler itself is looking what is the best way forward. That can bring problems with itself, because apart from the open source compiler like GCC, you've got the proprietary compiler from Intel and from AMD. And it is a well-known secret that the Intel compiler on AMD might not give the best performance and vice versa. Because the Intel compiler is optimized for Intel CPUs and the AMD one is for AMD CPUs. That said, if you know how to do it properly, and this is where all of the knowledge from EasyBuild comes in, if you know how to do it properly, you can get the Intel compiler to compile on AMD and it is not slow. It is also documented, so it's not a secret you only can find in a backdoor. I've been to an Intel workshop here at Imperial, because Imperial has a collaboration going on with Intel, and we got shown what is the best way of doing it. And this is exactly where EasyBuild is quite good. In some programs, it is actually actively checking what kind of architecture do I have, and then decides this architecture, so I'm passing on this compiler flags, and I'm doing it.
Maybe we can step back a little bit just now to talk about how EasyBuild came about. You already mentioned that it started kind of 10 years ago, but in Ghent, in Belgium. So could you explain a little bit more about the history, if you have that at hand?
It is, as far as I understand it, basically people were having the same problems as I explained earlier on, sitting down and compiling software, trying to work out what's the best way of doing it. And then if you think about it, that person is working in IT. By chance, it is meeting somebody from, say, chemistry, and they are compiling the same software. And another chance meeting is in physics. So 3 different people are compiling the software 3 different ways. So instead of doing it 3 different times, I'm always saying, do it once, do it properly, and forget about it. And this is basically where people realized there is an appetite for having a piece of software which does all of the heavy lifting for me, and this is one of the probably historic moments in software development where people are saying we need these kind of tools.
Okay, and that is basically what EasyBuild does. Are there any other tools that do something like EasyBuild?
Yes. If you look at history, quite often you will find that discoveries are made completely independently and come to more or less a similar solution. And indeed, in the US, there is a project called SPAC, which is funded by the US government. And they've got a slightly different approach, but basically they do the same. They've got some kind of instructions, of scripts, which are building software. The main difference between SPAC and EasyBuild, apart from SPAC is sponsored and EasyBuild is completely community-driven. The main difference is in SPAC, you can say, okay, I'm taking that compiler, I'm taking that BLAS library, and I'm taking that piece of software and so on, mix and match. And EasyBuild is, I take that compiler, that implies I've got this BLAS version, I've got this, I've got that.
Okay, does that mean that spec then is a little bit more versatile in the sense that you can determine yourself how things are being stacked up in terms of compilation and linking, etc.?
Yes. When I'm saying mix and match, I don't mean it in a negative way.
Mm-hmm.
So if you are a developer and you want to have a different toolbox, and you say, okay, I want to get the best out of the program, I want to have a certain baseline, but I'm trying out different versions of a library, for example.
Mm-hmm.
Here spec is brilliant because you just can do it. On the other hand, EasyBuild is, I was working through the pandemic in a hospital, and here reproducibility of, for example, COVID-19 testing is important. And as we all know, at the time, the whole field of COVID-19 testing was moving very rapidly. So you needed to make sure that the testing you are doing is reproducible in a different lab, for example, at EMBL in Heidelberg. And so everybody is working on the same piece of software, so to speak.
And it's comparable.
It is comparable, exactly. And here EasyBuild is quite good because you can say, okay, I was using that particular program with that version. And because EasyBuild is using a prescriptive way of installing software, that small piece of information was enough or is enough to tell you exactly how the software was installed.
So how do people get started? How easy is EasyBuild in terms of learning it?
It depends on what you want to achieve. It is basically one command. You need to install EasyBuild.
Yeah.
It is Python-based, so if you do very simple pip install EasyBuild, you are there. That's the easiest way of doing it. You can do it on any Linux machine, so that's it, done. And then in EasyBuild, you can say, okay, EasyBuild, just show me what kind of program you have, particular version or particular program. I'm just picking is CP2K. It's quite complex to install. So I'm saying EasyBuild, search CP2K, and it gives me a whole list of what is there. And then I'm saying, okay, EasyBuild, install CP2K. Again, it's a single command line. And then I'm going for lunch.
Okay, because it takes a while.
It does take a while, but basically if you've got a complete empty Linux machine and you just have installed Linux on it, what EasyBuild does is it is downloading the compilers, it is downloading all of the dependencies, it starts off building the compilers. Once you've got the compilers, then it's building the libraries. Once you've got all the libraries and all of the other things you need, then it is building the program, and in each step, if there is a testing which can be done, we are running the test jobs. So at the end of the day, you've got a working binary and it has been tested.
Okay.
And I think that is the important bit, because if you just say, okay, I'm just quickly running my program, you get a result. And I've done that the other day. I actually deliberately were running a program and I looked at the result and said, that doesn't work. And I upgraded my desktop machine at home. And I thought, I run it on a different location. That didn't work. And I ran it on previous location, and then I got a result back where I was saying that is okay.
Right. Okay.
But then I'm the expert here. I can see this is complete and utter rubbish. What I produced here, that doesn't make any sense. Somebody who is just starting to learn the program, and the program has been miscompiled, you get a result, but it is wrong.
Okay.
And if you don't run any test jobs, you lost.
What are the downsides? Are there any downsides of EasyBuild? Or are there any traps that people might walk into and find difficult to get out of?
Of course. I mean, each program which has a certain complexity has downsides. As I said, EasyBuild is quite prescriptive, which is good, but at the same time it is bad. Because talking now from the IT perspective, if you want to have what is called an easy config file, which is basically the recipe how to install software, and you are choosing a particular compiler, and you're unlucky, and that happened to me before, you're right at the end of all of the dependencies you need and so on, and then the test jobs are failing, then you find out that particular compiler version you cannot use because it doesn't compile properly. That means you have basically wasted 2 or 3 weeks.
Okay.
There is no way around it. In spec, you could say, yeah, compiler is very basic. You can't just flip it around. But in spec, you could say, okay, I just leave most of it. I just swap that bit of the program compilation out, which is causing problems, and I'm done. So the prescriptive way is quite good. But to get there, it's sometimes quite a mountain to climb.
All right. And you mentioned Linux. Is that the limitation as well, so it doesn't run on other operating systems? Or is there any particular Linux version that it runs on? Are there restrictions there?
In terms of Linux, it should be a recent one. So if you come along with a Linux which is 10 years old, you will find it very difficult. But that is just the age of the operating system, not because it is Linux. Linux is used on almost all HPC clusters. There are, I believe, only a very few around which are using Windows. Most of them are actually using Linux. So Linux is in HPC everywhere. In terms of other operating systems, that is a little bit more tricky, simply because it's using Python and it is very aimed towards HPC. That said, there is a different project which is called Easy, spelling is EESSI, which is a way of not installing software, but you basically just mount it, as it is called.
Oh, right, okay.
So just to touch on it, Easy is a way to distribute software, which is using a tool which comes from CERN. They are doing quite a lot in terms of HPC. And what you need to do is you just basically mount it on your machine and you say, okay, I'm running that script. That script is looking what kind of CPU you have. Remember what I said earlier on. And you get the high-performant software available at your fingertips. You might have noticed I didn't mention an operating system.
Indeed.
Because it is working on Linux, obviously. It is working on Windows subsystem for Linux. So you can use your Windows machine. And we are working on to get it done on Mac as well. So one of the big advantage here is, of course, for the HPC community. Instead of me sitting down and compiling software and burning energy, it already has been done. So I just mount it and I've got at least the big installations out of my way and I can focus on the more specific ones. As a user, I don't have to worry about software installation. I just mount it and I can play around with it. For example, get my input file correctly. When it is actually starting on the HPC cluster, after being in a queue for 2 weeks, or not 2 weeks, for say 2 days.
Yeah, let's say.
Yeah, that's, well, it depends on what you're requesting. Being in the queue for a certain amount of time, and then because I have a stupid mistake in there, it doesn't run, it actually crashes, and I'm back to a starting point. So you could do that on your laptop and say, okay, input file is correct, wonderful. I submit it to my cluster where the resources are a bit more precious, and then I'm just waiting 2 days to get it running. And once that is done, then I know it is starting and I know it should.
Okay, well, I think that's quite a lot to take in for the people listening to it. And thank you very much for your time, Jörg.
You're most welcome.
As Jörg explained, SPAC, spelled S-P-A-C-K, is the alternative build tool on HPCs. Usually you decide for one or the other, depending on your needs. Luckily, both SPAC and EasyBuild have extensive documentation, tutorials and introductions available, and you find the links to both in the episode notes. Also, I encourage you to check out the European Environment for Scientific Software Installation, or EASY for short, that Jörg also mentioned. Again, the link is in the notes. And now we come to the final part of the episode, the quiz. And there are 2 questions we have for you. And the first is, what is the main reason to use a tool like EasyBuild rather than installing software manually? I repeat, what is the main reason to use a tool like EasyBuild rather than installing software manually? And question number 2, why is reproducible software installation important? Why is reproducible software installation important? If you know the answers, you can email them to me using the Code for Thought email address, which is codeforthought@proton.me. That's code number 4 thought@proton.me. Or you can look up the address in the episode notes. I'll reveal the answers in the next bite-sized episode, which will be on the 29th of February, and I look forward to your quiz answers. Next on Code for Thought will be our monthly German language episode on the subject of women in research software engineering and in HPC. Thank you for listening to this episode of Code for Thought Bite-Sized. The content and the interactive bite-sized RSE sessions are created and run by Jeremy Cohen from Imperial College London and Steve Crouch from Southampton University. The podcast episodes are produced by Peter Schmidt. Finally, we'd like to thank Universe HPC for their continuous support. And with that, goodbye.